All right, so let's continue our lecture. Yes. Okay, so let's continue. Hey, sorry, I forgot to, project my. 可以帮我关一下后面的门吗？我怕吵到卢老师。帮忙一下，谢谢。OK。再一次分享荧幕好了，我很怕荧幕跑掉。OK， 好，好，那等一下那个助教就会来5点50分的时候，助教就会来发考卷，然后请大家去检查一下有没有问题，然后跟大家反映这样子。那一样跟之前一样，就是我不会回答问题哈，因为之前有一次就是我回答问题，然后跟助教改的标准不一样，然后害的就是说全班都要收回来再重改一次。好，所以我就相信助教，因为我都已经跟助教讨论过了哈，所以主要怎么样给分啊，我们都讨论过了。所以如果他是这样子的原则，我就不应该去覆盖掉他的原则。好，所以也就是说给予权利啊，就是要完全交给他啊。所以说有几次就是不小心，就是我讲出我的意见，结果反而造成他的不便啊，我那时候觉得有点不好意思。那所以现在应该都不会这样做。好，那5点10分的时候，他就会来发考卷，然后再来另外一点就是明天不用上课哦，原因是因为，反正就是我有重要的事情得去做，那很抱歉哈，那所以明天9点到10点是不用上课的。那因为要补这一门这个50分钟，所以接下来的5堂课在礼拜三的时候，我就会上到10点哦哈，也就是说接下来的礼拜三就是9点到10点会上60分钟的课程，然后上5次就会补足，好，所以请大家注意一下。那我也会我会请助教今天会公告在 Facebook 跟 E3 上。好，那提醒大家 ，OK， 所以明天不用上课，好，明天不用上课，然后接下来的礼拜三就会是多10分钟，多10分钟，多10分钟这样。好，那大概就这样。So I just want to say there is no course tomorrow, right? So no course tomorrow. To pay back the 15 minutes, I will split the 15 minutes into 5 lectures into 5 Wednesdays. All right. So start from next Wednesday, every Wednesday, I will give you 1 hour full lecture, and then for 5 times, for 5 weeks. All right. So that's the point. So yeah, let's continue our lecture now. Last time we talked about if we want to get the internal V and internal N in different position in the material, we need to cut it. We need to cut it and then leave the left-hand side, and then write down, assume the V downward, M upward, okay, because they are in rule, they are positive. Okay, so if you want to get the V and M across M0, you need to cut it and then you do the force balance, and then you can get a different value of the V and M. So you can imagine that different point in the material may have different value of shear and moment. Okay, this is the point. And then I want to ask, should we do all the time for every point by using cutting method, and we need to do balance for every point, do you think it's time wasting? So can we just find out the relationship to make some conclusion? So if we have some conclusion, and then we can just use the conclusion without doing the force balance, and then we can get the result, and we can get the shear and moment value for every point in the material. Okay, this sounds quite amazing, right? So let's continue. So last time we introduced, if the material encounter distributed load, what is distributed load will affect the V and M in the next point. Okay, next adjacent neighbor. Okay, so what will this contribute to the V and to the M? The contribution is dV and dm. Okay, because of the q dx. So here's some conclusion we made. You see, the first one is the slope of the shear diagram is the value of the distributed load. So dV over dx equal to q. So the slope of the shear diagram will be the q. Interesting. And if you do the integration, you will have shear force difference will be the area of the distributed load. Okay. And then your moment diagram slope will be the value of V. And the change of the value of the moment is the value, the area of the shear diagram. This is really interesting. So you can think that we convert the force balance into four conclusions. Okay, and then we can use this conclusion to speed up when we draw the shear moment diagram. Next, how about a point load? How about point load? How about the point load? Point load affect the M1 and V1. Sorry, how the point load affect shear force and moment. The point load here is acting on here, right? So this is single point. So because there's no need to do the distributed load, you don't need to do the integration. It's just there. It not like this. This q dx need to do the integration. So you see this is dv and dm, but point load just happen here. So you don't need to do any integration. So when P is here, your V1 and M1 is there. You don't need to do the integration. So this is not dm1 or dv1. No， 听得懂吗？就是前面为什么是写dm dv？ 因为前面是你需要做积分，你才会得到真正的值，所以你这边是dv dm。你要做完积分以后，你才会有值。但是现在你的 P 就是一经过这一点，你就得到这个力量。所以说你这个 V1 跟 M1 就是立即性的，不用去做积分，所以这是 V1 跟 M1，不是 dV 跟 dm 哦，这边要小心。All right, so what is the effect on of what is the effect of P point load on the velocity, shear force and the moment? So firstly, we just do the force balance, right? Sigma Fy equal to 0 and V1 V plus P minus V plus V1, and then you can see V1 equal to P. So this is V1 equal to P. So the fifth conclusion, the change 怎么在这里 ？Change the change of the shear force is the value of the point load. Okay? Your V1 equal to P. So the change of the shear force is the value of the point loads. This is our fifth conclusion. Okay? How about the moment change? The moment change, you see this dark blue dot, dark blue circles is our origin, okay? And this is dx over 2, okay? So you can see that here, you can see all the moment balance here. You see n clockwise, this n clockwise, so this is minus n, okay? And the p about the blue dot is counterclockwise, so it's positive. Positive p times dx divided by 2, no problem. How about v itself? It goes through the point, so no force arm, 0, right? We don't need to consider v. How about v plus v1? V plus v1 times dx clockwise, it's minus v plus v1 dx. And n plus n1. N plus n1 then is counterclockwise, so it's positive, equal to 0. So n1 to the left-hand side, okay? So n1 equal to blah, 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 blah. And you see, dx is small, right? Small, dx small, okay? So because dx is really small, so m1 is going to 0, okay? So normally point load won't change n, okay? n1 equal to 0, right? n1 equal to 0. So kind of going to, p doesn't change the moment. Okay, and yeah, the rates of change in moment. In the previous page, you know that in the previous page, this one, your dm over dx equal to v. Okay, and in the right-hand side, because you say dn over dx equal to the shear force, right? The right-hand side shear force is now v plus v1. So the shear force v plus P will be the right-hand side moment diagram slope. Okay, so you need to be careful. Although the point load won't change moment, but it will change the moment slope because the moment slope based on shear. So the P point load will change the shear value. So it will change the slope, but won't change the value of the moment. 听懂吗 ？moment 弯矩的斜率是根据它的剪力值，对不对？是前面那一页说的啊，是前面这一页说的。那可是啊，你看这个剪力，就是 P 会改变它的剪力值，不会改变它的弯矩值。所以说它的弯矩值不会因为 P 改变，但是那一点的弯矩值的斜率会改变哦，因为你改变它的剪力值。那这个剪力值就会改变那个弯矩值的点的斜率。等一下你就会知道，我现在讲好像有点复杂，不过没有关系，你大概就会知道说，虽然 point load 不会改变弯矩的值，当然它会改变弯矩的动向，因为它是斜率嘛，它会改变它的动向，你等下就会看到。Okay, so if you can accept this, we have one final condition. One final condition is for moment. Okay. And once you learn this, all 6 conditions, you will feel fun, relax when you draw the shear moment diagram. Very fun. All you need to do is just use triangle. The math you learned in junior high school. Okay, easy. Now, final condition. Final condition in next one. When you encounter moment, the moment n0, okay? Actually, we've done this before. We've done this in the previous case, right? Here. Okay, when you just pass through the m0, you will increase m0 in m, right? So actually, we've done that. So we make it systematic, okay? So we just make it again, make it more systematic. So now let's take a look. So again, we're using the blue dot for our origin, okay? It has V and N, and this is V plus V1 and M plus M1, okay? And N no. Again, you see that because the moment just there, okay? It's just there. So you don't need to integration for the dx. So the increase of V and M are immediate. So this is V1 and N1. No dV1, no dM1, because we don't need to do the integration through the dx. Okay? So let's continue. Right. So let's see if the M0, external M0 will change the V or not. 我们来看看这个外施的弯矩，外加的弯矩会不会去改变剪力的变化 ？Okay, let's take a look. So Fy equal to 0. Okay, so V1 equal to 0. So nothing changed. Okay, so applied moment won't change the shear force. Okay, nothing changed. Moment won't change the shear. How about moment? If the applied moment change the moment diagram value, yes, it does. Let's take a look. This is the origin. And the first one, N is clockwise, minus N. Okay? And N no, okay, clockwise, minus N no, no problem. And V has no force arm, so 0. How about V plus V1? V plus V1 times dx clockwise minus M plus M1 is counterclockwise plus, okay, equal to 0. And then, so cancel, and dx cancel. Wow, let's take a look. M and M deleted, and dx is small. Okay, so M1 equal to M0. Okay. M1 equal to M0. Remember what we did in the previous example, right? We pass M0 in the middle, and the moment increase M0, right? Remember this. So actually, we did it. We have done this before. So final conclusion: the change of moment is the value of the applied moment. Okay, so this is the final conclusion. Actually, we've done that before in the previous example, right? Now, I would like to give you more information about the positive value or negative value. Okay, so for the main surface, what is main surface? Main surface is this one. Okay, this one, main surface. Okay, for the main surface, N0 is going to bend the material downward, right? Downward. Downward, right? So in order to balance it, M1 has to bend upward, right? To balance it. So in this case, the moment in the material increase. Okay, so this is quite important. In your senior in the past few years, they always know, yes, M no will change N with its value. Okay, N1 equal to N no. Okay. But sometimes they will forget it should be plus or negative. They know the value will change according to the N moment applied, yes, but they don't know plus or minus. So here is the, conclusion that you can determine the direction. Okay, you can imagine that the N no is going to bend downward, right? You need to bend downward, but we shouldn't make it happen. We need to balance it. So we cannot make it downward. We should make it. We should generating one and one to against it. Okay. So if N not going to bend the main surface downward, the M1 need to be upward. So if this is upward, and it will increase the internal moment. Okay. So again, if your M naught in this direction, it will make it upward, right? So your M1 need to be downward. So the downward need to become negative. So you need to use in this kind of balance concept to understand the positive or negative of the M1. OK， 好，这边有一点点难，学长姐都会搞错。虽然我们都知道，这个 M1 一定跟 M0的值是一样的，但是学长姐常常都会犯一个错误，就是这边的正或负会搞不清楚。那这个正和负的搞不清楚的状况，其实是跟这个 M0的这个方向是有关系的哦。我们来想象一下，这个 M0如果是这样子做的话，这样子对于这个主角面来说，这是我们的主角嘛，对不对？这个主角面来说，它是要把它搬的往下弯的，但是不行啊，我们不能让它搬的往下弯啊，我们一定要把它抵消掉，对不对？如果没有去东西挡住它的话，它就会整个直接就把它折断，或者继续往下折，这样是不行的。所以我们这 N1 一定是要去抵消它，一定是要跟这个 M0的方向是相反的。那这时候我们就看M1 的方向是这样子，是跟 M0的方向相反。M1 的话是往上，那就是 internal moment， 内部的 moment 就会是往上加的。OK， 就 increase。但如果今天 M0是往这个方向，那你就会发现它是对于这个叫什么？这个主角面是往上搬的，它就会变成往上搬。可是不能一直让它往上搬啊，前面的 internal moment 内部的弯曲一定要抵消掉它，所以它会是 M1 是会往下的。那 M1 往下，也就是说它内部的弯曲要减少，才会 balance 这个 M0，对不对哈？所以这边就是必须要知道这个感觉哈。好，那这边蛮重要的，学长姐都会就是搞错正负号哦，所以这边是需要大家注意的。All right, next. So, okay, 好 let's continue. So let's take a look. Okay, this is one typical, very first example for drawing a shear moment diagram. So this is hinge, and this is roller, and you have a point load in P with length A and B. Okay, so now let's draw a shear diagram. Let's use our old basic method, cutting method. Okay, we are not going to use six conclusion for now. Okay, so let's just using the old way to do that. Firstly, I will draw a line here. Okay, and then I see that there must be a change in shear moment diagram in this force position. There must be change because something happened, right? During the journey of the x from x0 to x equal to 0, x equal to 0 and x equal to L. Okay, so the question, so the shear moment diagram should be V, okay, and N. So two empty figures here. The first one, V, and the other is N. And this is origin, x equal to 0. And of course, this is x. And this is x equal to L. This is x equal to 0. Yeah, you see that, right? So let's continue. First thing first, okay, we need to, after we plot the framework, empty figure, we just for now, okay? That's where we put our answer. But before that, we need to do the force balance. A and B. A is hinge. Hinge has two reaction force. However, there's no horizontal load. So this is the horizontal force, reaction force equal to 0. And this is RA. B has one reaction force upward. Okay, so RB. So you know that sigma MA equal to 0. So it will lead to minus PA plus RBL equal to 0. Okay, so RB equal to PA divided by L. Should be okay, right? You see, A is the origin. PA moment is clockwise, so it's minus. RB upward times L is counterclockwise about the A point. So it's positive, equal to 0, and then RB equal to PA divided by L. And you see no negative sign. So RB, we assume the good direction. Okay. Next, sigma Fy equal to 0. So easy. RA plus RB minus P equal to 0. So your RA equal to PB divided by L. Very good. So you see, RA, RB are very symmetry. So you know you get the right answer, right? So now you have done RB and RA. Let's use our old method to determine the value, okay? Bear with me for the difficult part. So if we want to know the value of V and N in this material, we just cut it, right? So because this P, we have two sections. Before P, nothing happened. After P, well, something happened, okay? So we need to determine two values for the shear moment, okay? So firstly, first cut. And then we have second cut. Again, I would like to ask, is there any difference if we draw this cut here or here or here or here? Does that make any difference? Anyone want to do the bonus? Any difference? No, exactly. You are right. So how about your number? 111, 613, 0037. Good. Very nice. Which means that actually this change, this cutting changed not the position. Nothing changed because there's nothing low, no loads in this region. But if you cut here, no, because something changed. P changed everything, right? So your one need to be in the left hand side. Your two need to be right hand side about the P. Very good. So the first cutting, X less than A. Okay. So we know that we need to leave the left hand side, right? And then this is RA, and this is V, and this is M, and this is length X. Okay, so we leave the left hand side, okay, and draw here. And because we cut it, there must be something in this main surface. Must be shear V and M. So V need to be assumed downward. M need to be make a smile curve. Okay. So we need to do the force balance. V equal to RA. No problem, right? And your N minus Vx equal to 0. Your N equal to Vx. Okay, what does that mean? You see, if we set this figure, this dot, this position as origin, your V is going to do the Vx moment clockwise, so needs minus Vx. N is counterclockwise, positive. N minus Vx equal to 0. So your N need to be Vx. Okay, you see, be careful. Your V before the P will be always equal to RA. Your RA is PB divided by L. PB divided by L. PB divided by L. Or, sorry, we shouldn't draw this. I should make it PB divided by L. So this coordinates of this red point is x equal to 0, y equal to PB divided by L, because your V equal to RA throughout entire A region. You see, V is a constant RA. I until it hit the P. Next one, your moment before P, M equal to Vx. Did you see that V is the coefficient, which is slope, right? So x equal to 0. What is the value? X equal to 0. M is 0. Okay. How about x equal to A? X equal to A. X equal to A. A substitute here. AV. M equal to AV. What is V? PB divided by L. So your value of this is PBA divided by L. Okay? This point, Y coordinate EBA divided by L. All right? So you see, what is the connection between it? Vx is a V is a constant. V is a constant. So M equal to Vx in the slope will be linear, right? So you just need to connect them. This is a moment. All right? So did you see the conclusion? M, the slope of M is its shear value. Yes, right? If it matched. Very good. Next one. Okay, next one. Our second section. Good. Second section. X greater than A. The second section, we cut here, right? Again, we cut here, doesn't matter, okay? Just between P and B. So we cut it, and we have a, okay. And we leave left-hand side, right? Always. And this is RA, and this is V, this is M. And of course, there's a P in the middle. Well, not middle. Yeah, there. And also, of course, the, sorry, X. Okay, this is X. And this is A. Right. So this is the cutting. Leave the left-hand side. All right. And then we do the balance again, which is a little bit more difficult. Well, just PB divided by L minus PL divided by L equal to minus PA divided by L. Okay, you see, because your P is here, so V downward, P downward, RA upward. Okay, so your V become RA minus P, so the V here become minus PA divided by L. Okay, again, when X greater than A, V become a constant. Okay, what is a constant? Minus PA divided by L. Sorry, minus PA divided by L. Okay, and remain constant between the P and the point B. Okay, so this is the shear diagram in this material. So the material in the beginning, the shear is positive, PBL, PBL, PB divided by L, PBL, PBL, PBL. After the P become minus PA divided by L, minus PA divided by L to the end. Let's take a look. What is the difference between it? What is difference? Force. P. Don't you think this is a little bit match the conclusion that we mentioned in the previous page? Shear, the value of the shear change will be equal to the point load, P. Very, well matched. Very cool. That's the beauty of physics. Okay? And how about moment? Moment n minus Vx minus PA divided by 0. How come? Here, again, this is the point origin. Okay? P is going to do the clockwise. So it's minus PA. And V is going to clockwise about the point A. So again, minus Vx. M is negative, clockwise, counterclockwise. So it's positive. Okay? Sum that together, and our M is PA times L minus X divided by L. Okay, looks a little bit ugly, right? But don't worry about this. Let's take a look. X equal to A, what will it be? L minus A. What is L minus A? B. PAB divided by L here. Okay, so the moment is still here. Okay, no problem. How about X equal to L? What is X equal to L? L minus L, 0. So moment equal to 0 at this point. Okay, and then you see this again, the X here is your variables, right? Your variables has constant slope. It must be a linear, although this is a minus slope. So the slope is minus slope. No. Linear. Okay, that's it. So this is the moment diagram, shear diagram. By using a, what's that? Basic, old way to do that, cutting method. So by using the conclusion method, I can draw this within 2 minutes before the break. All right. So I'll give you 1 more minute to draw this, and then I will give you really quick next. I will give you a solution 2 within 2 minutes.听得懂吗？这是用老方法 cut 剪断，然后去做力平衡，得到这样的 shear moment diagram。但是现在如果我们使用刚刚归纳出来的6个结论，我们可以2分钟之内就算出来了，就可以把这张图画出来哦，应该吧？但是首先我必须要先复制该复制的东西。 我要复制力平衡。好啦，我要赶快在2分钟之内把下一题算完了。I need to finish this in 2 minutes. Go. But I will skip the balance part. All right. So I need to draw. 2 minutes. 2 minutes. 2 minutes. 2 minutes. 2 minutes. Okay. Go. 0, 0, V, N. Okay. So you see, this is RA, right? RA. This is RB. This is P, right? So you see, the change in the shear force is the magnitude of the point load. RA is the point load, so it's upward. So it's upward. RA, okay? Nothing change. And the change in the shear force is the magnitude of the point load. P downward. Downward. This is P. And nothing change. Okay? This is minus P A L. Okay? Shear diagram done. How about moment? Moment here, you see, the change of bending moment is the area under the shear diagram. Sorry. So this is a positive PAB divided by L. This is the area, right? So the moment change will be this area. And this is a moment change in this area. And this is minus PAB divided by L. Okay? So from 0 to PABL. From 0 to this, from PABL minus becomes 0. Again, now the slope of the bending moment diagram is the shear force value. This is all constant, so just connect them. Done. Okay. Sorry, this is too quick. Okay, I will take slowly in the next after 10 minutes. Don't worry about this. I just want to show you that how quick it can be. All right. See you after 10 minutes. And if you have any questions, just come here. 喂，Welcome back。刚刚跟罗老师聊了一下天，然后罗老师在隔壁上，应该是应该是反正就是更高等的力学对了。那就希望有上过这门课的同学，对力学有兴趣的话，可以继续上罗老师的那门课。那罗老师那门课就是就是他是使用我跟他共同的偶像，叫做李巨老师，MIT 的李巨老师。是讲实在话，这样可能放到网上不是很好听，但是就是他真的是我看过世界上哇，真的是超级聪明的这种数一数二的人这样。那跟他聊天真的是如沐春风哦，就是你就可以看到他讲出来的话就是非常的，就是很有见解，然后又很绅士，这样子非常非常厉害这样。那我之前有幸跟他合作啊，哦，就是大家不知道有没有听过许家伟同学，就是他那时候就是那时候的同学都叫他公六馆的 AI 大神了哈，当然他已经离开了，他现在在 MIT 念博士，就是跟李居老师。那刚刚跟罗老师聊天，就是说他拿李居老师的讲义来，就是教大家嘛，这样。那里面看到就是有很厉害的计算，这样。那对我觉得很佩服。那对大家有兴趣，只是修完这门课以后，你可以去就是修一下罗老师的那门课，这样子。对，你会有更有感哦，更对于这个力学，这个应该说对力学的世界啊更有感。呃，也对啊，就是我最近每次都会跟我儿子说教，老人的说教，就会说教，就是说，是人生活在这世界上有什么目的呢？其实也没什么目的。那我自己觉得就是说，就是认识这个世界，跟认识自己，往外认识跟往内认识，大概就这样而已吧。哦，那你学这个东西就是认识啊，你认识这些东西，看这个世界就会更不一样，这样也蛮有趣的。好，就这样跟大家分享。Okay, let's continue. Sorry that I try to demonstrate how fast, how efficient this method is. So I just make it like just within 2 minutes or 3 minutes. Okay, I will take it step by step now. Okay, I'm sorry. So I believe you understand this. Okay, this should be fine, right? We just cut it and then we do the balance and then we can obtain the value in the material, right? Now, let's use the conclusion again. Okay, 6 conclusion, 3 of the 6. So firstly, the same problem, right? RA, RB, P. Okay, these 3 forces, and then we do the balance. We do RB, RA. We know the value. Okay, so now let's take a look at the beginning. At the beginning of the axis, x equal to 0. So you see x equal to 0 has a point load, right? RA, point load upward. So the change in shear force is the magnitude of the point load. So this is the point load, RA equal to PB divided by L. So starting from 0, boom, RA here. RA is PB divided by L, right? And then there's nothing here, right? Nothing here means 0 point load, right? So the change in shear force is the magnitude of the point load. Here, point load equal to 0. So nothing changed. So it will maintain the value of the force, shear force, until it meets the P here. The P here, okay, the change in shear force is the magnitude of the point load. Your change of the point load is P downward. So the PB divided by L minus P, the change, right? Change P downward. So PB divided by L minus P become minus PA divided by L. So this point is minus PA divided by L. And again, nothing happened. No point load here. So point load equal to 0. Nothing changed of the shear. Maintain the value into the end. Okay? And then you see minus PA divided by L equal to the value equal to RB. RB is PA divided by L. So you see they are the same value but different sign. Okay, they will cancel each other. Okay, so this is the shear force diagram. Very quick. How about moment? So let's continue our moment. Here, you see moment. Do we have any moments here? Do we have any moments here? Let's take a closer look. All right. Okay. At the x equal to 0, we want to determine very small, tiny step, V and N. Okay, so you see, do we have any moments here? Tiny. So your RA and V is really close to each other. Okay, very close to each other. And you can say this is dx. So this is a tiny dx times V. And the M here, internal M, should be 0. Okay, nothing here. So you start from 0, no problem, right? So you determine the first point of the moment. And second thing is that the change of the bending moment is the area under the shear diagram. This is our conclusion, right? So the change of the bending moment in this length, the change of the bending moment should be the area of shear diagram. So what is the area? PB times A, right? So this is positive PAB divided by L. So the yellow point, yellow area will be the, will be the value of this, because they change, right? The moment change from 0, of course, it should be adding up PAB divided by L. Boom, here. So I should make it the height, the change. Okay, the change. How about making how about this? Okay, the change will be the value of PAB divided by L. Well, it is positive, so I should make it upward. Right? Upward. Because this is positive. PAB divided by L. Then, next one. Oh, then you determine this one and this one. These 2 points, beginning point and the end point. How to connect them between the 2 points? We need to see the slope. The slope of the bending moment diagram is the shear force value at that point. Okay? The slope will be the value of that value of the shear. Okay? So shear force are all the same. So the slope will be the same, constant. So we need to connect them as a straight line. Easy. And then now you know this beginning point of the moment, PAB divided by L. How about this point? This point. So the change in bending moment is the area under the shear diagram. So the change point, change value will be the area of the shear diagram. So the shear diagram here is B times minus PA divided by L. So this is minus PAB divided by L. Okay? So the blue minus PAB divided by L. So, ta-da! Okay, downward. So you see, you change to this value. In between this region, how to connect them? We need to see the slope. The slope of the bending moment diagram is the shear force value at the point. Okay, so the slope will be this value. This value, what is value? Minus PA divided by L. They are minus value, so your slope should be minus. Okay, and then it's a constant connecting as a line. So you see, very quick, very simple. All right， 我们快速用中文讲一次哈，看哦，这边有一个诀窍了哈，就是你看这个区域，你就先决定前面的点跟后面的点，再考虑怎么连接它就好了。那这个连接它其实就是它的斜率嘛，好，所以你这边就是需要考虑。那像刚刚这个 moment 就很直觉啊，哈，你先决定第一点，再决定第二点，然后中间怎么连呢？就看这边的值是多少，你就知道该怎么连。OK， 那这边也是啊，而且它的变化量就是它这边的面积啊，所以还蛮好玩的，就基本上就把面积算一算，就可以得到它的值，蛮简单的哈，蛮好玩的。Okay, so you see the conclusion, sixth conclusion can significantly speed up how you draw this shear moment diagram. Okay, very good. Next one, I will give you more examples and then you will understand how the conclusions helps you. Okay, help you. Next is the distributed load. Okay, this is distributed load. Q. We want to know the internal shear and moment. Okay, again, RA and RB. RA should has RAH, but there's no horizontal force, so it equals to 0. Okay, so I just didn't plot it. And then the first things we need to do is determine the force balance. What is RA? Okay, what is RA? And sigma MA equal to 0. So RBL minus QL times L divided by 2 equal to 0. How come? Okay, you see, Q is the distributed load. When we do the force balance, we were using effective load, right? Resultant force, QL, in the middle, of course, because it will go through the centroid of that area. What is centroid of area of this rectangle? Halfway, right? Half L. So this is how half L comes. And QL is the force. So QL rotate about the A clockwise. So you get minus here. How about RB? RB is counterclockwise about A. So RBL is positive. Okay? And then you have RB equal to QL divided by 2. And sigma Fy equal to 0. So you have RA plus RB minus QL equal to 0. So your RA equal to QL divided by 2. Well, don't you think it's too easy, right? Just maybe you can just see it and then you get the answer immediately. But it's okay. Now, let's draw the diagram, shear force and moment diagram. Okay. Okay. 0, 0, V, N. Okay. Of course, this is x equal to L. This is x equal to 0. Let's take a look. So suppose we don't have anything changed here, right? We don't have anything changed here. So we don't need to draw a line in here, okay? So we can assume that there will be a kind of a sustained change in the shear, okay? So let's take a look. The change in shear force is the magnitude of the point load. You see there's a point load RA, right? RA point load upward. So you change your shear QL divided by 2 because RA equal to QL divided by 2. RA positive. Next, be careful. All right. So what is the endpoint? What is the endpoint for the for the shear? The endpoint is the change in shear force is the area of the distributed load. Oh, what is the distributed load area? QL. QL. The change of the shear force will be the area of this distributed load. So here, area is QL. So during this L, QL divided by 2 minus QL is minus QL divided by 2. Okay? After going through this L, the change of the shear force is the area of the distributed load, QL. Okay? So QL divided by 2 minus QL become minus QL divided by 2. Now, how to connect them? The slope of the shear force diagram is the value of the distributed load at that point. So you see the slope is of the shear diagram is the distributed load value Q here. So you see the slope of the shear force will be a straight line. Straight line. Okay. So that's the shear diagram. Okay. How about moment? Now, I will give you one important concept here. Did you see that? Of course, our moment will relate it to shear, right? Your shear diagram changing the status. So it must doing something about the moment. So don't worry, you need to adding a section from that point. Okay, so be careful. All right. Next. Again, you see nothing here in moment. So the moment start 0. Moment start 0 because there's nothing here. Nothing about moment, right? And then the change The change in bending moment is the area of under the shear diagram. So during this section, the change of moment will be equal to the value of the area. What is the area? This area. This area. Okay, what is this area? And this is a positive. Positive. Okay, what is the value? The value here is QL divided by 2 times half L divided by 2. Because this is a triangle. So it should be QL squared divided by 8. And this is positive. And you see that this height will be QL squared divided by 8. Okay? So you know the difference between this section. So 0 to QL squared over 8. The 8, this area, the QL squared divided by 8 is the area of the shear diagram. Okay? How to connect them? Slope, right? The slope of the bending moment diagram is the shear force value at that point. Oh, careful. Shear force value keep decreasing to the 0. You see, previously the value is QL divided by 2. So which means that the slope of this point will be the slope of the moment diagram is QL divided by 2. Okay, how about the midpoint? The middle moment point is 0. So this moment at this point should be slope 0. Okay. So you see the moment slope from QL divided by 2 and then gradually change to 0, gradually decrease to 0. So you can imagine that here, slope gradually decrease and get to 0. You see that? This is really important, okay? Because your shear force is keep changing their value, which means that your moment of slope changing too, okay? Next, quite easy. Negative area. What is the value of the area? Minus QL squared divided by 8, right? So your value, the change in bending moment is the area under the shear diagram. Now, during this section, your moment need to decrease by QL squared divided by 8. Yes, it's go back to 0 again. And how to connect them? The slope of the bending moment is equal to their shear value. You see, at the beginning, it should be zero slope. And then finally, it become more negative. More negative. So the slope is equal to minus QL divided by 2 because its shear value is QL divided by 2 minus. Okay, so you see flat slope equal to 0 and negative, negative, more negative, more negative, more negative become minus QL divided by 2. All right, so that's the shear diagram. All right, that's how we draw it. So you see, there's nothing, apart from the very beginning of the force balance, all you need to do is just using the 6 conclusions, and then you can draw all the beautiful shear diagrams. So let's take a look. Which point will be the most moment value point? Center, right? You got the biggest moment, internal moment in this material. So you need to take a closer look if this material will break at that maximum moment occurred. Or you can say this material may have certain shear breaking criteria. You need to take a look about this point and that point because your biggest shear occur here and there. OK， 听懂吗？就是为什么要画这张图啊？是因为你就可以知道这个材料里面哪里的剪力是最大的啊。这里就是这边最大，这边最大。你要看中间吗？不需要，你的剪力破坏不可能会出现在中间的，因为它是0啊。好，那但是中间会有什么破坏？弯曲破坏，它的弯曲是最大在中间啊。那你要看弯曲破坏，不用看左右两边，是看中间。OK， 所以它的弯曲的最大值会出现在材料的中间点，但剪力的最大值会出现在左右两边。这就是我们画剪力弯曲图最重要的地方。所以你可以想象一下，我们这些梁跟柱的shear diagram跟moment diagram是哪里会怎么样？因为我们把我们的东西放在这个楼板上，你可以想象，例如说我们的楼下这个好了，可能这边会比较重，因为这个讲台放在这里，所以这边的力量就会比较大。那这边有个 distributed load 讲桌，对不对哈？不对，讲台，这个讲台是 distributed load， 对不对？所以你就会发现，这上面其实有很复杂的载重，你大概就可以知道这个梁大概会怎么样的受力状况啊，这就是这样。So I'm just saying that in the real world, you can now examine how the force, shear force and moment distributes in the beam above you in the ceiling, because all these ceiling support the floor. Okay, you see this stage, table and the stage, they all give you the point load or distributed load for the beam. Okay, so this is the way we know where is the weakness point of the material. All right, next. Now, getting more complicated, but don't worry. We just use the same concept throughout the chapter. And again, you need to be really careful. You need to learn everything in the chapter 4. Otherwise, chapter 5, you won't solve anything. Because every problem in chapter 5, you need to do force and shear moment diagram. Okay? First, otherwise nothing you can see. You can get anything. You cannot get anything. All right, so now this is a sectional bending, uniform loads in the material. So you see this Q here has an effective load in the middle, in the centroid of the area of distributed load. So this is QB, only this section B, QB, all right? Now, of course, this length will be half B, all right? It will be a little bit complicated at this time, all right? But still, not too difficult. Now let's continue to determine the RA and RB, all right? So I will make it quicker because you have done this many times. QB minus QB times A plus B over 2 plus RBL equal to 0. So your RB equal to QBB plus 2A divided by 2L. Okay, you see that it's kind of getting more complicated. And sigma Fy equal to 0. So your RA minus QB plus RB equal to 0. So your RA equal to QB and B plus 2C divided by 2L. Good. You see that again. The value become always gets the symmetry, right? RA, RB, QB times B plus 2A divided by 2L. And RA is QB times B plus 2C divided by 2L. You see, this is a little bit kind of symmetry setup of the loading. Okay? So we are pretty much that our solution is kind of should be more, we feel more confident about this, the value we determine. All right, so start drawing the shear moment diagram. Okay, 0, 0, M, and the V. All right, so another thing you need to see that this is a little bit 3 section for the shear. Okay, must be that looks like this. They have some, changing section. All right, so this is, of course, this is X, right? This is X. Now, let's continue, right? Let's draw V shear force. A point load upward. So the change in shear force is the magnitude of the point load, right? So RA, this is RA upward, and nothing happened. Okay. And then how about distributed load? The change in the shear force in this section is the area of the distributed load. The area of the distributed load is QB. QB. So RA minus QB. What is that? RA minus QB. We need to minus QB. Right? Minus, because QB is downward, right? So QB minus. And right. So you can RA this stuff minus QB. What will we obtain? What will we obtain? Let me tell you. minus RB. Okay, maybe you think, how can you know that? Because we can inversely guess that, right? You see, you know this point has RB, so you know that there must be RB in the end to fit this RB, right? So, and nothing here, so that it needs to be connected. Okay, so actually, I don't really need to determine RA minus QB. Wow, this is ugly. Minus QB. It must be equal to minus RB. Definitely. Okay, I promise. Because you can see the end of the material. It need to be minus RB. OK， 听得懂吗？我说啊哈，你看哦，我的 RA 到这里了，那 RA 经过了这个 B 小段，它的简历的变化值会是什么呢？会是这个分布载重的面积嘛，对不对？好，这面积是 QB， 所以实际上我要正统算的话，应该是 RA 哦，这个 QB 乘上 B 加21除以2L， 要减掉 QB 啊，然后算完以后就会发现，哎，其实它等于 RB。啊，你等下你可以自己回家算算看，但是我不想算，为什么呢？我可以用一个更聪明的方式，我们可以看到这边最后面，因为这所有东西都一定要是立平衡的嘛。你看到最后，它这边就是 RB 啦，表示说这边一定是负的 RB 在这里，它往上推回去就可以抵消掉。OK， 所以这边一定是负 RB。那可是你看中间什么东西都没有啊，所以中间什么东西都没有，表示说这边的解力值会跟这边的解力值会是一样的。所以你看后面虽然是负 RB， 前面这边一定也是负 RB， 那它就直接连在一起了。OK， 所以实际上我不需要把这个东西减 QB 得到 RB minus RB， 我可以从后面推回去得到负 RB。当然这都是经验了哦，你可以慢慢的把它减掉 QB 得到负 RB。OK， 这是没有问题的。All right, so let's continue. But we still have something I haven't done. We need to connect them, right? Connect them. How to connect them? Of course, straight line. Why? Because the slope of the shear diagram is the value of the distributed load at that point. Your distributed load is Q, 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 Q at all the points. Okay, so the slope will be constant. The slope is constant, should be linear. So just directly connect the 2 points, and then you can get the shear load, shear force diagram. Okay, so your shear force diagram done. How about moment? Hey, and you see that there's one more section appear. So you need to add up one more section for your moment diagram. Okay? So now, let's continue. Moment. There's no moment at the point A. Start the point 0. And how about that? There's nothing for RB. There's no moment there, right? It must return to 0 point. Okay? So suppose it should be, looks like that. So you see that the moment diagram must be something in between, in between. And you notice that the area here is positive, and here is negative. It must be increased here and then downward here. So you can kind of understand the trend should looks like that, right? 你知道我在讲什么吗？你前面已经知道它的 M 会是0的，后面什么东西也没有，它一定会是0。然后你可以知道这边是正的 area， 这边是负的 area， 它一定是先升然后后降，回归到原本的0。好，所以你也可以预期说这边的 area 会等于这边，不然它不会回归到同样的0啊，对不对？所以大概是这样啊，所以有很多的感觉啊，可以慢慢的去思考。接下来是最难的部分 ，OK。I don't know if I have time to do that, but I encourage you to do that at your home. Okay, it will be really fun. So, the thing is that the first area RA times A will be the value, right? The area. So the area change of the shear force diagram will be the change of the moment value, right? So RA times A, RA times A, RA times A should be here. Okay, wait a minute. Should be here. Okay? I times A should be here. And then what is the slope? Your shear constant, right? So just connect them without doubt. Okay? Of course, the slope. What is the slope? I will give you a chance. Who will answer this and will get a bonus? What is the slope of this line? Anyone? Very nice. RA is a slope. Okay, what is the number? 13619. Yes. Sorry. 11613 019. 019. Okay. Very good. The slope. I guess I need to stop here and let teaching assistant to give you the midterm. Okay. So I will stop here and I encourage you to go back home to continue. And then let's match our answer next week. No course tomorrow. Okay. I'm sorry for that. And yeah, if you have any questions, just come here and I will give you the distribution. Okay. It's really interesting that the exam and midterm has exactly the same average. And this average is about right, 60. 60. So yeah, that's your distribution. And I gave you the warning for the last 30%. So yeah, be careful. And yeah, hope you can learn something here. Okay, thank you. Any question? Okay.